Alright, today's lesson is lesson number, that's a lie, it's 69. We are going to continue factoring, specifically dealing with difference of squares today. Remember, difference is subtraction, right? Difference in math is subtraction. So that's going to play a big role in today's lesson. So we're going to be factoring difference of square binomials. So there'll be two terms, and we'll be able to factor that. We're going to specifically be focusing on math practices 7 and 8, so we'll be looking for and making use of structure and expressing regularity in repeated reasoning. So basically we're going to be able to reason from these problems and see that we can use this kind of a shortcut here. Okay? So here are our steps. First of all, we want to make sure that we can apply this rule. So in order to do that, we have to have a binomial with two terms where the first term is squared, then we have a minus sign, and then a squared term after that. Okay, so two terms, both of them are perfect squares and a minus sign in between them. Then we'll take the square root. So if we can apply this rule, we'll take the square root of the first term and write it into the beginning of two separate parentheses. Okay, then we'll take the square root of the second term and write it into the end of the parentheses and put a plus sign in one and a minus sign in the other. Okay, so this is kind of the going backwards of the shortcut that we learned in the last section, last kind of unit. We talked about polynomials. Remember how we could do this shortcut where we say, okay, I have the same thing, but it's one's plus and one's minus. So, I can just square the first term, square the second term, put a minus sign in between them, and I'm done, right? It came from the fact that when we do the rectangle here, we get x squared plus 4x minus 4x minus 16. So the middle terms kind of cancel out, so we just get x squared minus 16. Okay, so over here, so that's what we were doing last time. Now we're going backwards, so we want to get back to this expression. So we're doing the opposite. So instead of squaring the first term like we did to go this way, we are taking the square root. Okay, so we take the square root of x squared, I get x and put it here. Take the square root of 16, I get 4 and I put it here. And I put one plus sign and one minus sign. Okay, so moving on, here's our first two examples. First I'm going to look at 9. I want to see, okay, what are the factors of 9? So I know, okay, 9 is like 3 times 3, so that's 3 squared. So that's a perfect square. And it's being multiplied by x squared, which is a perfect square as well, so that's good. The 4 is just 2 squared, right? 2 times 2, so that's a perfect square as well. And I have subtraction going on between them, which is the last condition that I need. Okay, so I'm going to erase this so that I can write this a little neater. 9x squared, that's just like 3 squared x squared. And then minus 4 is just like 2 squared. Alright, so I take the square root of each of these terms, the square root of 3 squared times x squared. One of each of them get to come out, so it's 3x, and then square root of 2 squared. Again, this is just like 2 times 2, so 1 makes it out, and I have 3x and then 2, and 3x and 2. And then I put a plus sign in one and a minus in the other. It doesn't matter which one you do first. You could do either one. Okay, that would be our answer. Alright, number 2, I'm looking at the factors of 49. I know 49 is just like 7 squared, so I have 7 squared n squared, and 144 is 12 squared. Okay, so I can apply this rule. I'm going to take the square root of 7 squared n squared. That gives me 7n. I'll write that in the beginning of each of these parentheses. I take the square root of 12 squared. That just gives me 12, right? They cancel out, or I can think of it like one of them gets away, right? So this is 12 at the end, and then I put a minus sign and a plus sign. Put one of each. Okay. Moving on, 3 and 4, again, are similar. So in class I had students do this on their own now to show that they understood. And then we went over it. So this is the square root of 9b squared is, well, first we realized we could apply this rule because we know everything there is a perfect square. So square root of 9b squared is just like the square root of 3 squared b squared. So 3b comes out. Square root of 25, it would just be 5. So I write the first one at the beginning of the parentheses, the second one at the end, and a plus and minus sign in between. Okay, moving on to number 4. Same idea. I'm going to look for what the square roots of each of these are. I know 121 is just 11 squared, so it's going to be 11k. So I'll write that at the beginning of each. And the square root of 36 is 6, so I put that at the end. One's a positive, one's a negative, and I'm done. Okay, one of the nice things about this is that, again, it's kind of like a shortcut. We could technically do an X box here, but we just have to remember that we have a B of 0. Okay, so look at number 3, for example. I know my A is 9, so I put 9 there. But I don't have any term that has just a B in it. That would be my B term, right? So if I just have a single variable, that would be my B term, right? I normally have ax squared times bx, or sorry, ax squared plus bx plus c. So I have A and C, but not B here. So let me back this up a little bit. So I can multiply A and C, A times C to get what goes on top, which 9 times negative 25 is going to give me a negative 225. Negative. Okay. And then I see what factors of that multiply to negative 225 and add to 0. So if they add to 0, they have to be the same number, just one positive and one negative. Okay, so I know that 225 is 225 is just 15 times 15. So I can use those as my factors and make one of them negative. Okay, then I'll look at these fractions. Look at the fractions, and I see that I can simplify 9/15. That's just 3 over 5. I can also simplify 9 over negative 15. That's just 3 over negative 5. Okay, so now I would have I'd be able to write the factored expression that we wrote, right? This just goes to 3b plus 5. This goes to 3b minus 5. So we could do that, but it makes the numbers bigger and it's a little more work. Okay. Remember, again, our trinomials that we were factoring are of this form. Okay, so that's where a, b, and c come from. So this is really just like saying 9b squared plus 0b minus 25. Okay, so that's why we have a 0 down here below. Okay. Alright, moving on to 5 and 6. Now I'm looking, can I apply this rule? I see 9. I know 9's a perfect square, 16's a perfect square, but I have addition going on between them now, not subtraction. So it's not a difference of squares, so I say this is not factorable. There's no GCF that I could factor out either, right? Nothing like that. So these are both not factorable. And I could check that. I can check that by looking at the factors. Again, I could see, okay, wait, can I factor out something? Is there something that I can do? But looking at these factors on number 5, there's 3's and 4's, which I guess we could narrow down to 2's, but they're never gonna be there's never going to be a common factor there. And same thing with number 6 is all, for 9 it's just 3 times 3, and then 64 is just a bunch of 2's. So I don't have a common factor there either. I could also try to use X box here. So on number 5 I would have this. So I put my 9 on the line on either side, and then 9 times 16 is 144. Okay, I could get 144 by, I could get 144 by multiplying 12 times 12, but the problem is that I really need one of those to be negative in order for them to add to 0. But if one was negative, I would have to have negative 144. So this just doesn't work. This is not factorable. Alright, and that's all for today's lesson. We just reflected on what we learned and did some independent practice. So if you want some extra practice, go ahead and practice these problems and pause. I'll show the answers in 1 second. Alright, and these would be the answers for those. Okay, again, 7 and 8 would be not factorable because there's addition happening between them. Alright, that's all for today's lesson. Have a great weekend, and I'll see you on Monday.